April the 24th, 2026. Guys, we've had three strong flares. The last two were X flares, and they're coming from this sunspot right here that's slowly drifting around this edge of the sun. But I think I know the reason why it's suddenly become active. It's been quiet the whole time. There was the first X flare until it got to this position. We're going to take a look at maybe why. Here comes the second X flare. Check this out. Right there. Amazing amount of energy displaced. Let me stop this just a moment, back it up. Look at that. There's your X flare signature, and it would have been stronger than that, guys, as far as the sensors from our satellites, if it had been directly Earth facing. But this was an X 2.4, I think. And let's go back through. Here we had a strong flare. Look at the spiral. Then back-to-back X's right there. Look at that. Wow. The energy is amazing. But it's an electrical universe, and we're seeing a discharge event. Check that out. Look at that fan out. Wow. Now, here's what's happening. And we may get a glimpse of Comet Panstarrs here in just a minute, coming right down towards those sunspots. But something happened. Notice it's the 23rd right there. We get it for about one frame, and then the camera goes off yesterday. I've got the still shot, though. Let's take a look at it. It's, again, though, it stopped on the 23rd. As soon as the comet started coming in to this area, you may get a glimpse of it right there. You see that? And this is the last one that has come in from the satellite, right there, the 23rd at 15:18 UTC time, and there is Comet Panstarrs, and the sun is greeting it very loudly, if you want to put it that way, very powerful. Don't know why we don't have the other data. This satellite, the Comet Panstarrs is probably much further into the frame after this many hours, because I saw this frame yesterday. And when I saw the update this morning, I knew they hadn't changed anything. So I'm not sure exactly why, if one of the flares or something like that shocked the optics on the cameras of the satellite. I've seen that happen. They can sense a surge, a solar burst or something, and then basically power down to preserve their optics. And this is the problem sunspot right here, 4419, been relatively quiet. You know, it takes about 27.5 days to rotate around the sun. And so it's been up here for a couple of weeks. Now, 4420 is starting to get a little larger. And if we're starting to see activity increase on the sun, then this is where it's going to come from, more than likely, because we're already getting multi-colors here. And the different colors represent different polarities, and that's where you get your arc on the surface. And this is the X-ray flux chart. It lets us know the power of these flares. And the X flare line is right there. See it, guys? Right there between the X and the M, and both of these crossed at this one. I think they were both about 2.45s. They're very close. Look at that. And that's what we're seeing, and we're still seeing some activity here. But this could increase. We may get another solar flare today, another strong one, because of the proximity of Panstarrs there. Now, this is kind of the layout for this morning. It says 4419, that sunspot just produced another X flare, this time reaching X 2.52 at 8:13 UTC. The suddenly hyperactive sunspot region continues to rotate closer towards the northwest limb. The first X 2.4 solar flare at 107 hurled a CME to the northwest that so far appears to be off the Sun-Earth line. The latest event will likely produce a similar outcome, and there are going to be, of course, more to follow on it. The second update is the flare on Friday morning was indeed responsible for an impressive coronal mass ejection that is headed mostly away from our planet. You saw it moving off to the right. A new tracking model released by NASA is also showing mostly a miss, with perhaps the extreme edge of the plasma cloud passing close to Earth upstream. Only a glancing blow at best should be expected. That's a good thing. You're still going to feel the effects. The event is associated with a Type 2 radio emission. And guys, here's the kicker. The speed it left the sun at 1,293 kilometers per second. This was an impressive coronal dimming. A large CME will be produced. Due to the location nearing the west limb, it should be directed mostly away from the Earth. And again, look at this. Type 2 radio emissions, estimated velocity, 1293 kilometers per second, guys, right there. Let's see how fast that is in miles. And this is what we get, guys. 1293 kilometers per second is 2,892,359 miles per hour. See that? It's almost 3 million miles an hour. That's incredibly strong. What you do, you take the kilometers per second and multiply the speed value by 2237. That's what we have. We got almost a 3 million mile per hour CME glancing off the sun. Now, this is a great still shot of the explosion, the 2.5, guys. Look at that. Look at the amount of material. Again, the sun, if you went across the surface with the exact scale of the Earth to the sun, it would take 119 of our planets to make that crossing. And look at the size of the explosion. That's unreal. Any planet that was involved in that right there, if you had a kill shot, it would pretty much do a lot of damage to our atmosphere, much like what happened to Mars, if I'm not mistaken. Now, this is Enlil's solar wind prediction model. What you're seeing is the burst that we saw at the beginning of the video from the sun flare to the left. Then we see this smaller burst right there. I don't think either one of the X flares have been tracked yet, but they would be off in this direction, moving towards stereo A, which is the red circle right there. Now, even though this one was a powerful flare, it wasn't quite an X. You see how it's going to skirt the Earth right there? And that's going to create a plasma density brick wall right there. And that's on the 25th. That'll be early tomorrow. And then our radial velocity is not that fast. Check it out, because it's such a glancing blow. Now, when they start tracking those X flares, we're going to more than likely see an impressive speed. I don't know. Again, we're looking at nearly 3 million miles per hour. We'll see how that relates to the models here. Now, guys, check this out. This is the image of Comet Panstarrs, guys, from ground-based telescopes. Look at the coloration in it. And you're just seeing a glance in this still shot of the tail. I'm going to scroll it up. Just pay attention. This is from Frank Niebling on April 18, 2026. Pixel Skies, Spain. That's unbelievable. Look at that. You see these sections right there, guys? I've seen it before when a coronal mass ejection or something like that can sweep out and completely tear the tail off, and then the tail will reform as the increased solar wind. Like again, we've got solar wind now at nearly 3 million miles per hour. That will pull that tail away, just tear it in half and push it out, and then the tail will start reforming. We get some more images after we see what impacts the CMEs have on the comet. That may very well show up, but again, I just want to scroll this thing up. There's one of Elon's satellites right there. Very big, very beautiful comet. Amazing what this universe can throw out. And this one kind of wraps the whole thing up. This is Roger Menard, April 17th from Rockwood, Texas. Guys, check that out. Look at this. Now, that's what a comet is supposed to look like. Not like what Atlas was showing us. Nothing like that at all. But this is how we see them. And this is really one of the longer tails that I've seen. And I've seen a lot of them, guys. But let's bring this up a little bit. I want to show you the coloration behind the actual comet itself. Check that out. That's amazing, isn't it? You've got gold and green mixed in here. And again, the tail sweeps back for quite a while. Coloration remains in there. But that's Panstarrs, guys. Again, I just wanted to come in and talk about it. When we get some models tracking those two X flares, I'll come back and we'll get a brief update. I'm working on a very interesting video. Started on it yesterday and worked on it into the night. I should finish it in the next couple of hours, I hope, and I'll get that up to you guys. It's about CERN and some of the events that are going on there and how it will affect the rest of the planet and possibly history, possibly biblical history. Anyway, guys, we're watching it. You watch it. It's a heads up. Be safe.